In this video, I'm going to go ahead and walk you through your assignment, interpreting exponential functions and their graphs. So in problem number 1, we are given the equation. We're given the equation P, which is equal to 1500 times 0.98t. And what this represents is the population of lions between the years 2010 and 2013. So about how many lions were there in 2010, and how do we know this? Well, since my equation starts at 2010, we know that the general form of an exponential is going to be y equals a times b to the x power. So a is my starting point or my y-intercept. So when I'm asked about how many lions there will be in 2010, I look at that number and we know there's going to be about 1,500 lions in 2010, because this is the y-intercept or starting point of my equation. Part B asks what's happening to this population over this decade. And we can see that my growth factor is less than 1. So any growth factor that is less than 1 is going to represent a decay. So describe what is happening. We can say that the lion population is decreasing. I know this because my growth factor is between 0 and 1, and that indicates a decay. So how many lions are there in 2023? That means I'm going to take my equation and I'm going to go ahead and plug in, not 2023, I'm going to go ahead and plug in 13, because it's been 13 years since the start of 2010. So that's how my equation works. It starts at 2010, and every year I'm then collecting data on my lion population. So in Desmos, let me actually go ahead and delete this. In Desmos, I have 1,500 times my 0.98, but that's been raised to the 13th power. And so you can see here, I have about 1,100 or 1,153 or 1,154 lions. You can't have partial lions, so I don't care how you round here. I think I'm going to go ahead and round to 1,100. So this was what we got on our calculator, I think. And so the lion population in 2023 is going to be 1,000. Let's do this. Is about 1,153, no, 54. I'm going to round up. 54 lions. Okay, second problem. A new online music service has a collection of 1,500 songs. It is expected to triple the number of songs each year for the next few years. Let's write an equation that represents this relationship where X is the time in years and Y is the number of songs available. So remember, any exponential equation is going to be in this form, y equals a times b to the x, where a is where we start and b is how we grow. And so where we start is 1,500 songs, and how we grow is that we triple the number of songs each year. So there's my equation. Part B says, well, how many songs will you have in 10 years? So the way my equation works is if I go ahead and, since x represents time in years, if I plug 10 into x, I can go ahead and find my answer. So that's going to be 1,500 times 3 to the 10th power is going to be, 8,857,000. I'm not going to remember this. Let's see. 857. Nope, 350. Okay. I had that wrong. Whoa, so about 88 million in 10 years, they will have about 88, actually, let's be precise here, 88,573,500 songs. Okay, number 3. F represents the amount of medicine in milligrams. So that's what mg stands for in a person's body, T hours after taking the medicine. So we're given a graph, and my first question asks us, how many milligrams of the medicine did the person take? So we know that the person took, if this is my starting value, 80 milligrams. Person took 80 milligrams of the medicine because this is the y-intercept. So write an equation that defines F. So all we need is a starting point, which we already have, and we need to know how it grows. So I was at 80 milligrams 2 hours after I was at 20 milligrams, which means that what was happening at 1 milligram, if we continue on like this, so this is going to be 1/2, which is going to be 40 milligrams. And then if I half 40, that's where I get 20 milligrams. If I half 20, I get 10 milligrams. And if I half 10, I get 5 milligrams. So we kind of have to read between the lines. So again, my initial points were every 2 hours. So if I want to figure out what's happening every hour, I have to think about what's happening in between here. And so that's going to be a decrease of about half each time, which gets me to 1/2. Okay, so don't forget your exponent. It's not going to be x, it's going to be t because of this f of t. So if I want to know what's happening 7 hours, that means I'm going to take my function, I'm going to plug 7 in, and then I'm going to use my calculator. I'm going to use my calculator to go ahead and evaluate that. So let's see. I'm at 80, 1/2 raised to the 7th power. So there's about 0.625 milligrams still left in my system. Milligrams left in the person's body. Right, number 4. Jada saw a music video that her favorite artist recently posted online. The equation is going to be given by V of t, so that's 320 times 4 to the t. Represents the number of views that the video got. We already can understand pretty quickly that the growth rate is greater than 1, so I am definitely getting more views as time goes on. But t represents the day since Jada saw the video. So the question is asking about evaluating V at -2. Just like I've done before, I'm going to take -2 and I'm going to plug it into my equation. Don't worry about solving that by hand because I'm going to come over here and I'm going to plug that into Desmos. So, gosh, 320. And my growth factor was 4 raised to the -2nd power is going to be 20. So V of -2 is 20. Part B, though, asks, what does this represent in this situation? So because we have a negative, what this means, since t represents time, that -2 means to go backwards in time. So this would be V of -2 is the number of views, right, which is 20. That's what we just found here. So the video only had 20 views before Jada saw it, 2 days before Jada saw it. the end.